Well, in this video, I'm going to show you how to download the Anaconda distribution. This is a distribution that I recommend the most. So basically, you can just download this package here, and it comes with like an entire toolkit of pretty much all the things that you'll need at least when you're starting. So I'll give you Python itself as well as all of the major libraries. So you can get this by going to anaconda.com. This is all 100% free. And download whichever Anaconda version fits your operating system. And I'll give you a second. Now, once you've downloaded this, you can take a look at the navigator, where basically it has all of these, all this different functionality that you can use. And what we're going to focus on here is the Jupyter Notebook. And basically what this is it runs an instance of Python in your web browser. And from your web browser, you can write all the code that you need to do. So once you're ready, click on Launch. And once you launch, it'll come up to a screen with the Jupyter Notebook inside of your browser. And it'll take you to Home. And what you need to do now is figure out a place where you want to save all your files. So the data set that we're going to use, you can find that in the description below and link to it. And you should save that data file somewhere where you know you're going to find it. So for me, I keep it in Documents, and then inside Documents I have Python scripts. And in this instance, we're doing the Titanic. So you can just save it there. But basically what you need to do is find a location where you're going to put it and make sure that you can remember that and you can just keep going there. So once you kind of manage your way through your libraries and put things where they need to go. So again, for me, I go into Documents and then I create a new folder called Python scripts. And today we're working on the Titanic, so I created a new folder called Titanic. And the data we're going to use today is train. So if you look at it, it's just a CSV file, comma separated file, CSV. And it just has information on passenger ID, whether or not the individual survived or not, passenger class, name, sex, age, fare, how much they paid. So what you need to do is to go into your Jupyter Notebook and create an instance of Python. So I've done this already. That's what I named Titanic Descriptive Statistics that we're going to do today. And how you access this is you go to New and then go to Python 3 or whatever pops up here, your instance of Python. And you can use this to analyze the data. So here's a look at some of the code that you could write to analyze this data. And basically, the first thing you need to do is to bring in all of the different packages that you're going to use. So within Python, there's a whole bunch of different packages that are written into Python to help us with specific functionality. And you're going to see these ones again and again. So Pandas. Pandas is really important, very critical. It's used kind of like Excel, where basically it's kind of like a spreadsheet. And NumPy and PyPlot and Seaborn. These are all ones for data visualization. These are ones that you'll use quite a bit. So make sure you have all of this information in. And in Jupyter Notebooks, the way to enter code so that it runs is to press Control Enter, and it'll run that code for you. To skip from one to the next, you do Shift Enter. And if you want to add a new line of code and go to the next one, you do Alt and Enter, and it'll create a new line of code for you. So here we bring in all of our packages that we want: Pandas, NumPy, Matplotlib, Seaborn, and they're brought in as certain abbreviations, and this is kind of just standard and customary to call Pandas PD, NumPy NP, PyPlot, PLT, Seaborn, SNS. And now that that's in, the next step is to bring in the data set actually into this instance of Python. And to do that, you're using a function within Pandas where you're bringing it in, where it's PD, so it's calling in Pandas, and it's read underscore CSV, so we're reading in a CSV because that's the type of file that we have, and it's called train.csv. Note that this query will only be successful if where you're writing this code, so remember we create a new instance of Python in this folder that has the train.csv in it. This will only successfully retrieve this data if it's in the exact same folder, so be careful of that. Now that we have the data inside, the most common way to make sure that your data actually came into Python through Pandas is to take a look at it. And one command that you often put in is the name of the dataset and .head. So when we came in and we brought in train.csv, we named it Titanic. We could have named it whatever we wanted. So for instance, we could go back and just name it C. And if we call in just C, it'll do the same thing. But instead, we're going to call it Titanic. So what you call it is pretty arbitrary. Just know that you're going to need to call in the same thing as what it's called over and over again, or else it's not going to know what you're asking. So for the head function, you can write as much as you want. You can say 5, that's the normal amount, or you can ask for 10. And then the opposite of head is tail. So head is asking for the first 10, and tail is asking for the last 10. And you can just edit this however you wish. Another common thing that you ask for in Pandas is the describe function that I find to be pretty important. So describe, you get just descriptive data on all of the different variables that you have. So it looks like overall there's 891 pieces of data for ID, survival, passenger class, and fare, and there's missing some data for age. And it gives you mean, standard deviations, and then the spread of the data, which can be pretty helpful. Another function that's pretty important is finding the mean of all these and grouping it by different areas. So we could find the mean earlier just by using the describe function, but to break it down by different groups, you can do passenger class. That can be one that you can do, and it'll give you all of the data that's broken down. That way, you can also do it by survival. Let's take a look at that. And for survive, it looks like the ones that didn't survive were slightly older, they paid a little bit more, and they had a higher passenger class, meaning they're less likely to be first class. Another function that you often do is trying to graph all the data. So in Pandas, you're able to do all of this kind of basic stuff to take a look and describe your data. To be able to visualize your data, that's when you often use different packages that are made specifically for that. And the one that I tend to use the most is called Seaborn. And Seaborn, you can go to their site. All of these different packages and everything, it's all open source, it's all free. And to get good at this, basically what you need to do is kind of dive into the documentation, see what the different packages allow you to do, and just kind of learn from there. So at Seaborn, it shows you kind of like all the different things. There's a tutorial and then different pieces of information on the site. One thing that's pretty cool, I think, is the correlation plot. So to do this, you just type in correlation and you kind of just follow all of the syntax. You can change things. You can make the X ticks and Y ticks bigger, change the size of it. You can change the color of it. And basically what you're looking at is correlation between different variables. So what we're interested in is survival, and it looks like passenger class is most strongly related to survival, and looks like fare is pretty in there as well. So that's one look of a way you can break down data. Another one is to do what they call a joint plot. You could also call it a scatter plot. And basically, we're looking here at passenger class and whether or not the individual survives. So that's one thing you can do. Another thing you can do, we could look at fare and see what that shows. Shows overall that same kind of trend where you're more likely to survive if you paid more money. We could also try age. And looks like older you are, looks like there's a slight decrease in the amount you can survive. And you can also do simple bar plots, looking at the differences in survival between males and females. You can change it to other things you could do a bar chart with. You can do passenger class. You can just look at the same data in just different ways. So it looks like passenger class 2, passenger class 1 survived a little bit more than passenger class 3. And lastly, this pair plot function I think is pretty interesting. So in this data set, it's actually not as informative in my opinion, just because it's so overloaded with data points that it's kind of hard to pick out what's what. But you can change the size of this by typing in a function in here to allow that to happen. But if it gets too big, it's kind of hard to see what happens. But sometimes when you have smaller data sets, using the pair plot function is a good way to go. So in Python, this is the way you bring in data, and this is at least a way to look at what you have, to look at descriptive statistics, to look at correlations, to visualize what you have. So it gives you an idea of what's going on before you get into the machine learning sections. So I hope you enjoyed this and found it helpful. Thanks for watching.